Example 9. The probability density function of a continuous random variable x is defined as follows. So you are given the PDF. For the part A, obtain the cumulative distribution function. So you need to find the CDF from the PDF. So from the PDF to CDF, you need to integrate. You need to integrate every single function that listed here in order to find out the CDF, which is the capital letter of F. So we have been discussed the same example from the previous one, which is the example 8. So the big difference from the previous example to this one, for this example, you are given more than one non-zero function, which is you have 1 and 2 non-zero function. Okay, so before we form the CDF, we do the working for finding the CDF. It's better we write it in this form, in this kind of interval, in order to identify how many interval that we should find out the CDF. So we just denote all the given interval starting from 0 until 1. Okay, from 0 until 1, and followed by 1 until 2. So 1 until 2. So since we have two non-zero function, which is, this is for the 6x over 17, this is for the 6x squared over 17, and 0 for the otherwise. So altogether means that we can notice here, altogether we have 1, 2, 3, and 4 interval that need to find out the CDF. Okay, so we're going to start with the first interval. The first interval is for the x less than 0. So I'm going to write on the interval first, or the 4 interval. I'm just going to write on all the 4 intervals. So from the x less than 0, and then followed by x greater or equal than 0, less than 1, and then followed by x greater or equal than 1, less than 2, and lastly the fourth interval for x greater or equal than 2. Okay, so then we are going to continue with the finding of the CDF. Okay, for the first interval, the capital letter of fx should be equals to integration of negative infinity. It should be from the negative infinity until x. Right? It should be a negative infinity until x. So the function that should be right on here should be 0. So integration of 0 function will give you 0. Okay, and then the next column is finding the f of c. F of c is actually the upper limit for that interval. Okay, so since this is the x less than 0, so this is the upper limit. So we are going to find out the f of 0. Right, f of 0. So this is the 0. So 0 need to be substituted into this function. So 0 substitute into the 0 function will give you 0. With f of 0 equals to 0. And then we are going to proceed with the second interval. For the second interval, the f of x should be, okay, second interval is starting from 0 until x. Okay, we should start from 0 until x. So since this is a cumulative, it should be cumulative from the beginning. So before we start from 0 until x, we should start with f of 0. So f of x is equals to f of 0 plus with 0 until x with the function 6x over 17tx. Right, so f of 0 we have calculated from the previous part, which is f of 0 equals to 0. Then you just need to integrate for this function. 6x over 17 equals to 6x squared over 2 times with 17 with the limit 0 to x, which is equals to we can cancel out this 3x squared over 17. Right? So we have done for that part, and then we're going to proceed for the f of c. So f of c is f of 1. Why it is 1? Because the upper limit here is 1. So I'm going to find out the f of 1. The maximum here is 1. So substitute 1 into this fx, this function. So substitute, we are going to have 3 times 1 squared over 17. So we will get 3 over 17. Right, then continue with the next interval. Okay, for the third interval, we're going to write it as a f of x equals to, okay, for the third interval, this is the third interval, we are going to integrate from 1 until x, But you have to remember that before we entering this interval, we have accumulate from the beginning. So the accumulation up to 1 is referring to the f of 1. So we're going to write it here, f of 1 plus with 1 until x, with the integration of the function 6x over 17 tx. So f of 1, we have find out the f of 1 from this part. So we're going to substitute here 3 over 17 plus with the integration of 6x over 17. You will get 6x squared 6x squared. This should be 6x squared. Then this should be 6. Wait, I'm going to erase this. This should be from 1 until x. So then we get 6x cubed over 17 with the limit 1 until x. Right, we are going to solve it. 3 over 17 plus with this integration, so 6, this substitute the limit, so 6x cubed over 17 minus 6 times 1 cubed over 17. So then, if we simplify every single things here, I forgot here, this should be 3 here, 3. Right, so at the end, after you simplify, you will get 2x cubed over 17 plus with 1 over 17. Or you can rewrite it in the single form, single fraction, which is 2x cubed plus 1 over 17. Okay, so for the last column is a f of c, so it should be f of 2. So f of 2 need to be substituted into this function. 2 needs to be substituted here. So f of 2, it should be equals to 2 times 2 cubed plus 1 over 17. So then you get 1 here. Right, so proceed with the last interval. So the last interval should be f of x equals to f of 2 plus with 2 until x with the 0 function. Okay, we are going to start with the f of 2. So f of 2, since 2 is here, so we're going to integrate 2 until x, but before 2 until x, we already accumulate until f of 2. So f of 2 until integration of 2 until x with the 0 function. So f of 2 we have find out from this part, which is f of 2 is this one, which is equals to 1. So 1 plus with the integration of 0 equals to 0. So you will get 1 for this part. Alright, so we have done for the CDF. And then write down the final answer. You have to write down in piecewise form. So f of x equals to, okay, just copy down all the CDF that we have find out starting from 0 and then followed by this one, followed by this one, and up with 1. Okay, you just copy down all this answer into the piecewise functions. So the final answer should be 0 for the x less than 0, 3x squared over 17 for the x varies from 0 until 1. This is 2x cubed plus 1 over 17 for the x varies from 1 until 2, and lastly 1 for the x greater or equal than 2. Right, so we have done for that part. We are going to proceed. Right, so proceed with B1. The question asks to find the property of x less than 3 over 2. So since the notation already in the form of less than, so we can just straight away write down px less than 3 over 2 equals to the f of 3 over 2. Okay, we are going to use the CDF since we already calculate for the CDF. We have found out the CDF. So you just substitute 3 over 2 into the correct function of CDF. So we have to find out where is the x equals to 3 over 2. So back to the answer here. So 3 over 2 is 1.5. So 1.5, it should be around here. Okay, it should be 1.5, it should be around here. This is 3 over 2. So means that we have to substitute the value of x, which is 3 over 2, into this function. Okay, we are going to substitute here. So means here equals to 2 times 3 over 2 squared plus 1 over 17. So that will give you 31 over 68. Right, so then proceed next. Next question asks to find the greater x greater or equal than half. So you have to do something on that before using the CDF function. We need to change a bit. So px greater or equal than half is equals to 1 minus px less than half. So then we are going to use the CDF. So is equals to 1 minus capital letter of f of 1 over 2. So we are going to substitute 1 over 2 into the correct function of CDF. So back to this one. So 1 over 2 is here. This is 1 over 2, 0.5. So it should be substituted into this function. So then we're going to substitute here. It should be 1 minus 3 times 1 over 2 squared over 17. So equals to 65 over 68. Wait. 65 over 68. Right, so continue. Next. Okay, next is x greater than 3 over 4, less than 4 over 3. So this one you just need to write it in the form of CDF, which is equals to f of 4 over 3 minus with f of 3 over 4. So you just need to substitute 4 over 3 and 3 over 4 into the correct function. So find out where is the 4 over 3. So you just need to okay, check it here. So that 4 over 3 need to be substituted into the second function, and 3 over 4 into the 4 over 3 into the third, 3 over 4 into the second. So you just substitute. So here it should be 2 times 4 over 3 square over 17 minus plus 1. Wait. Should be plus 1 minus with 3 times 3 over 4 squared over 17. So then you get 103 over 432. Right, lastly, Lastly, find the median. So the median is, how to find the median? The median is f of m equals to 0.5. Okay, so we have to find out this value where it's cut the total area into half, which is equals to 0.5. Okay, but before that, we have to check out which interval that should be m's located. So I'm going to go back from the previous part. Okay, so let's go through the last column here. The last column here, we have found out the f of 0 equals to 0. So this is, since this is 0, so this interval is not going to be your m's. M is not going to be here because the cumulative here until 0. Right, and then f of 1, if we calculate f of 1, we get 3 over 17. So 3 over 17 is less than 0.5. It is less than 0.5. We want to find out 0.5. If the cumulative is less than 0.5, then m should not be here. M should not be here because when you substitute the m into this function, you won't get 0.5 because it less than 0.5. The maximum area here is 3 over 17. It is less than 0.5. Right? So means here, means your m, so meaning that your m should be located in this interval. Okay, m should be here since the cumulative here is until 1. So means from 0 until 1, the total area here is just until 3 over 17. Okay, from 1 until 2, the total area is 1. Okay, the total area is 1. So means 0.5 should be here. So this is your m. So after we have found out the location of m, okay, just find out it correctly. So then you can just substitute the m into that function. So we are going to substitute m into this function. Right, so back to this part. Since m should be in between of 1 until 2, so means that f of m should be equals to 2 times m cubed plus 1 over 17 equals to 0.5. Okay, so we're going to solve it. So 2m cubed plus 1 equals to 17 multiplied with 0.5. So the m cubed here should be 17 times 0.5 minus 1 over 2. So that will give you m equals to 1.55. So since this is the only solution for m, okay, and then before that, just to make sure it is in the correct interval, just check whether it is included between the correct range. So since this is in the correct interval, so that's the final answer. So the median here is 1.55. Okay, now let's discuss the last example for this chapter, which is example 10. The cumulative distribution function, or in short form is CDF, denoted by the capital letter of fx of a continuous random variable, is defined as follows. For the part A, the question asks to find the values of the constant A and B. To find all those values, you have to be clearly understood that since this is a continuous random variable, the term continuous itself is already described. It should be continuous. The function should be continuous on every single x for the given interval. So in order to do that, just check the given function. So since this is the A and this is the B, so to find out the A, we can substitute, whether you can substitute the value of 0 or the value of 4 into the function of fx, the CDF function. So I'm gonna substitute the value of 0. So if you choose to substitute the value of 0 into the function of f, so it means that we have to substitute the value of 0 also for the function before that, for the second function. So I'm going to write this equation become f of 0 equals to f also f of 0. Okay, why we equate this f0 equals to f0? Because since this is a continuous, when we substitute 0 for this function, it should equals when we substitute this 0 into this function. Okay, in order to make sure it's continuous on every single x. Okay, so to differentiate between these two substitutions, I'm going to write this as a negative here to represent the left side and the positive to represent the right side. So means that f of 0 to be substituted to the function for the left side, and the other one, f of 0 or positive, means that 0 to be substituted on the right side of the function on the right side. So for the f of 0 from the left side, we're going to substitute, I'm going to erase this. So we are going to substitute f of 0 for the left side, which means that for x less than 0, so substitute for this function, we are going to have 1 over 12 times 2 plus with 0, x will be 0, equals to, substitute this 0 for this function, which is a plus x over 6, x will be 0, so 0 over 6. Okay, just be reminded that this negative and positive signs just to differentiate which function that need to be substituted. Right, so we are going to solve it. So for the left side, we are going to have 1 over 6. The right side, you are going to have the a. So the a is 1 over 6. Okay, then we're going to find the value of b. So since this is the b, so the function b plus x over 12 is for the interval 4 to 6. So we're going to choose either one of this value, whether 4 or 6. So I'm going to use to 6. Because when we substitute 6, which is 6, we have to substitute 6 into this function. And also substitute this 6 into the next function. So this is quite easier rather than choosing the 4. So I'm going to write here, write the f of 6 from the left equals to f of 6 from the right. So f of 6 from the left, we're going to erase it. F of 6 from the left means that for x less than 6, I'm going to substitute this. So it will be b plus x will be 6. 6 over 12 equals to, this one equals to 1. So since 6 from the right side is this function, represented by this function, so we're going to solve it. So b equals to 1 minus 6 over 12, which is 1 over 2. So b will equals to 1 over 2. Okay, then we're going to proceed with the part B. So for part B, the question asks to find the probability density function. So this is the PDF. So I'm going to back to the question. Okay, you have to be reminded that if we want to convert from the CDF, okay, the question give you the CDF, and then you need to convert it to become a PDF function. So what kind of operation that need to be used here? So from the CDF going to change to PDF. So of course we need to differentiate. We need to differentiate all those CDF function in order to get the PDF. So CDF, or you can denote as a capital letter. This is the fx. So the target here is to finding this one. So we are going to differentiate every single function that listed here. Every single function need to be differentiated. Okay, so we are going to start with the first function, which is 0. Right, so I'm going to write here. Okay, so I'm going to denote here by first. First means that for the first interval, which is for x less than -2. Okay, we want to find the PDF. So in order to find the PDF, we have to differentiate the CDF. So the CDF for this function is 0. So if you differentiate 0, you get 0. And then for the second part, second interval, which is x varies from -2 to 0. To find the PDF, we have to differentiate the CDF, which is, the given function is 1 over 12 times with 2 plus x. So we are going to differentiate this one. But before that, it's better if we simplify this one first. So if we simplify, you get 1 over 6 plus 1 over 12x. So differentiate 1 over 6, of course, 0. Differentiate 1 over 6, 0. Differentiate 1 over 12x will give you 1 over 12. Okay, next, the third function. Okay, so this is the third. This is the first, second, third, fourth, and the fifth function that we are going to differentiate. So we have settled for the first, second, and then now we are going for the third. For the third function, from 0 until 4, the function here should be a plus x over 6. Since a is 1 over 6, so now we are going to differentiate. But before that, we should write the interval here, which is x varies from 0 until 4. Okay, to find the fx, we have to differentiate a plus x over 6, which is a is a 1 over 6 plus x over 6. So differentiate 1 over 6 will give you 0. Differentiate x over 6 will give you 1 over 6. Then we're going to proceed with the next function, which is the interval for x varies from 4 until 6. Okay, so the PDF is differentiation, is a product of differentiation of the function here. The function for the fourth interval is b plus x over 12. So b is 1 over 2. So we're going to substitute here. So it will be 1 over 2 plus x over 12. So differentiate this one. Differentiate 1 over 2 give you 0. Differentiate x over 12, you get 1 over 12. Okay, lastly for the x greater or equal than 6, so the fx is differentiation of 1, which is 0. So we have done for the differentiation all the function, and for the final answer we have to sum up all the function that we have find out in a piecewise form. Okay, which is the final answer should be rewrite in this form. Right. Before we rewrite, let's check the fx that we have find out, the product of differentiation. Since we have 0 here, and this is 0, this 0, this 2 0, we are going to combine it. We are going to rewrite, you have to write down here is 0 for the otherwise. And then if you check this one, okay, so I'm going to write this for the 1 over 12. Okay, 1 over 12, 1 over 12, this 1 over 12 for the given interval. So I'm going to write this as a final answer, 1 over 12 for the function, for the interval x varies from -2 to 0. And then next we have 1 over 6 for this interval. Just copy down. So 1 over 6 for x greater equal than 0, less than 4. And lastly, also 1 over 12. 1 over 12 for x greater or equal than 4, less than 6. And 0 for otherwise. 0 is combination of these two intervals. So we're going to write it as otherwise. So that's the answer for the part B. So for part C, the question asks to calculate the probability from 3 to 5. So since you have two options to calculate this probability, whether you are going to use the CDF or PDF. So since we already have the CDF, it's better we're going to use this CDF. It's much easier rather than use the PDF. So I'm going to use the CDF, which is a capital letter. So to find out the probability of x greater or equal than 3, less or equal than 5, it is equivalent to f of 5 minus f of 3. We are going to substitute this this maximum value, okay, the maximum value minus with this minimum value. So we're going to substitute 5 and 3 into the correct function. So since this is the CDF function, you have to be careful that you need to substitute this x into the CDF. So the CDF function is whatever given into the questions from the starting itself lah. So we're going to substitute the 5 and 3 into this function, not the PDF, okay, not this one, okay, not the PDF, it should be the CDF. So we're going to substitute 5. So check the 5, where is the 5? So 5 is in between of 4 and 6, so we're going to substitute here. So F5 should be, B is 1 over 2, plus with X is 5 over 12, minus with F3. F3, we have to check where is the F3. F3 should be here, in between 0 and 4. So we are going to substitute into this one. So it's a minus of A. A is 1 over 6 plus X over 6. So X should be 3. So calculate at the end, you will get 1 over 4 as a final answer for part C. So that's all for the last example.